I mean, I guess I'll skip a little bit about that, but and just I don't know, plug the RASC a little bit. I'm a member of RASC Montreal, Canada. The RASC was founded in 1868 and is Canada's leading astronomy organization with over 4,000 professional and amateur astronomers, as well as educators across 29 centers throughout Canada. We are the largest and most active astronomy group in Canada. The Montreal Centre specifically was established in 1918 and has about 170 members of all ages. RASC Montreal has plenty of awesome special programs, which we host. We obviously have public events and talks, kind of like the one I'm giving right now. We have a great clubhouse near St. Anne de Bellevue. We have a newsletter called Skyward, which accepts submissions from our members. We have our own Bellevue Observatory with a 14-inch telescope. The time of recording recently upgraded, I believe. We frequent a place called a dark sky site. That is to say, it's a really dark, excellent place for astronomy. It's called Woolly Woods. There, the sky is so much more visible than in Montreal, something I will talk about a little bit later. We have observing events, star parties and workshops, which are great opportunities to socialize and take a telescope out with you and go observing with the club. Every so often, the Montreal Centre gets together at the I.K. Williamson Library for good snacks and even better company. It's really a lot of fun. So also for those of you who want some hardware for yourselves, telescope rentals and a swap sale are a great place to get some. And if any of that sounds interesting to you and you want to learn more or, join the center, which I highly recommend doing, our website is rascmontreal.org, which I can paste in the chat to, near the end or something, if people are so inclined. If you have any questions, you can contact the Montreal Centre directly through this link here, which, I can also paste in the chat near the end, but if people are inclined, we can do that. Saturday, August 8th, that is to say tomorrow at 8 p.m. EDT, there'll be another free public event specifically on the Perseids, as I understand it. How to observe them and techniques related to photographing them. So if that's something you're interested in, the meeting ID is in this photo, and I'm sure that also circulates. Can put that in the chat too if we want. Some of our partner events here that are worth mentioning. Cette partie est en français. The International Day of Astronomy this year will take place online, hosted by Université de Montréal, and aussi des astrophysiciens de l'Institut de recherche sur les exoplanètes, IREX, vous guideront pour une séance d'observation du ciel nocturne à distance. So you can take a look at IREX's Facebook page for stuff about that, and that's taking place August 12th at 7:30. So, before we sink our teeth, I guess, into the night sky and the Perseids, I guess I want you guys to know, a little bit about me quickly. My name is Julian De Silva. I'm 21 years old. I'm currently a student at McGill University. I'm extremely passionate about astronomy and science communication. I think that science communicating is incredibly important. And I think that one of the best ways to get people excited about science is through astronomy. It's a lot of fun, and it's an honor and the privilege to share it with you guys today. Thanks for coming, and if you're seeing this after the fact, I guess thanks for watching. So our mini talk today is called Perseids and the Night Sky. So I kind of want to take us on a trip, a little bit of an adventure through both, I suppose. There are two big topics today. What we'll get to see in the night sky this weekend. This weekend, I suppose, being August 7th to August 8th and 9th, and the Perseids Meteor Shower. So I guess first I'll introduce our dynamic and ever-changing night sky, and maybe learn a thing or two along the way. Learn about what we get to see and when we get to see it, and then afterwards we can go right into the Perseids. By the way, while there was going to be a 20-minute Q&A session at the end of this presentation, I don't know if that'll still happen, but at the end, we'll reserve some time for that. If you do have burning questions like right now that you want to ask, I don't have the chat open right now, but I guess unmute yourself maybe, and we can go about it that way. Yeah, so anyway. So the first question you might be asking is, what is there actually to see with your naked eye this weekend? Isn't astronomy mostly done with telescopes? And well, that's true. Yeah, telescopes are great for astronomy. Don't get me wrong. But without any tools at all, you'll be able to see quite a bit. This weekend, I want to focus on 3 things that you'll be able to see. Constellations, many of which visit every night. Some of which do not. Earth's neighbor, our moon, and excitingly, some planets will be visible this weekend for you to see as well. I got a thing in the chat, I believe, though I can't seem to see that. Okay. Should I take a look at this? We'll be talking about that in humans. Ella wants to know where meteors come from. Oh, that's a good question. And yeah, I will be talking about that. Do not worry about that. Is there a way to start this from current slide? Okay, awesome. Yeah, so yeah, we'll get to meteors. Yeah, don't you worry. So let's take a look at constellations first, though. So out there in the darkness of space are stars, which shine so brightly that we can see them from super far away from here on Earth. From our perspective on Earth here, sometimes those stars that dot the night sky align themselves in such a way where if you use your imagination just a little bit, they look a bit like pictures. Now, I obviously wasn't the first one to notice this, of course. Ancient civilizations a long time ago, like Indian, Chinese, Arabic, and Greek, all had astronomers who noticed these patterns, right? In fact, many constellations are named after Greek heroes and mythological stories. And here in these pictures, that illustrates that, right? This is a mythological figure, Hercules. That's the Nemean lion from the Hercules story as well. And this is these two pictures on the right here, from my perspective, is the mythical hunter Orion, and like a picture overlay of that. Now, I mentioned earlier that some constellations we don't get to see every night, and some of them we do. So why is that? Well, the constellations that we get to see depend on the time of year and our latitude on Earth. Now, latitude is a term I'm sure many of you watching are familiar with. It specifies on a globe a particular line, how far north or how far south you are relative to the Earth's equator. That's the middle. Now, to demonstrate why that might be important, I'd like you to consider what you might see looking up and out into space from the red point I put on the picture of Earth on the right, versus what you might see looking out into space from the bottom half of the Earth at the red dot near the bottom, right? Clearly, these two perspectives would actually be very different, right? One would be looking up and out into space, right? Looking upward, and one would be looking down and out into space, right? Because space is all around us, right? Up, down, left, right. It's in 3 dimensions, right? In other words, we wouldn't be able to see the same stars in our field of vision from these two different points. So a change in latitude, change in latitude changes what stars we're capable of seeing. If you were to take a vacation to Australia or South America, the sky would look very different. But how different, and in what ways? And this may seem like a little bit of a sudden segue, but I absolutely love flags. So I couldn't help but merge two of my favorite things here, astronomy and flags. And I want you to take a look at these two flags over here. This is the flag of Australia and the flag of New Zealand. Now, both of these feature a constellation here called the Southern Cross, also known as the Crux. And why is that? Why might that be? Well, they use this constellation because it's actually exclusive to the Southern Hemisphere. You'll never see the Southern Cross in Canada or anywhere in the Northern Hemisphere, incidentally. But these countries, like in a way, then like identify with this constellation, which is kind of cool. Now, in a similar way, right, the Big Dipper, Little Dipper, and North Star, among others, are exclusive to the Northern Hemisphere, right? People in the southern half of the globe will never get to see them without taking a vacation towards the north, right? Now, I also put another flag here. This is the flag of Alaska. And they also seem to be super proud of a constellation in the sky. They're proud of the Big Dipper and the North Star, and they put it on their flag too. And then, you can kind of see that. I kind of tried to orient it there. This is a picture of the Big Dipper in the background and the Little Dipper. And at the end of the Little Dipper on the right, the end of the little ladle at the end, that's the North Star. So I kind of wanted to overlay that there for you to take a look at. That's really cool in my opinion. I have a lot of fun with that. So these stars, which are exclusive to either hemisphere, by the way, they're called circumpolar stars. Only in the north or the south, right? Never both. They're called circumpolar because they seem to rotate around the poles. And there's a list over here if you're super curious. So, I said Little Dipper, Big Dipper, the North Star, and then some familiar constellations like Cassiopeia and Draco. And the Southern Hemisphere, the Southern Cross, aforementioned, and then Carina and Centaurus. But some constellations can be seen actually in either hemisphere. These constellations are in the night sky in one hemisphere, and then months later, they dip below the horizon and appear upside down in the other hemisphere of the world. These constellations are called seasonal constellations. And like here are a couple examples. Like right now it's summertime. So in the evening, like this evening, if you're living in the northern hemisphere, you could step out and you could see Cygnus, which is a swan that's pictured on the left. In the winter, you can see Orion, pictured on the right. And vice versa would be true in the south, and they would end up appearing upside down. So Orion would kind of be standing on his head. Mind you, not all these constellations are terribly easy to see sometimes, and can be a little difficult to spot for the first time if you haven't seen them before. So, you might be asking, like, how do you find these kinds of constellations in the sky? So, I mean, I was expecting, like I said, more people. I was going to do a little bit of a demonstration here, but our one and only esteemed guest should have received one of these. It's called a star finder. I kind of want to show a little bit about how to use it right now. So you have these two pieces of cardboard here that construct your star finder. The first step is to put it into the holder here. Should look a little bit something like this. You can follow along if you happen to have it. If not, that's quite all right. I'm gonna go slowly enough that I think you can figure it out. You fit it into the holder here, and on the back you can close up the flaps here and keep it steady. But make sure that it has enough room to move. Okay, I want you to see that. You have to make sure it can move a little bit. So after that, you have to line up, as you can see here on the top here, there are the months, right? That's showing up backwards in my camera. I don't know if that's showing up fine on your end, but there are months on the top there, right? So what we want to do is we want to line it up with the current month. So it's August, and there are also small markings, kind of like a ruler on the right underneath, and that's gonna tell you the day. And so what you see here is that there's also the time, the time of day here. Right? So there's midnight, 1 a.m., 2 a.m., 3 a.m., right? And so what you want to do is you want to line up the time with the day. So if we were going out on August 8th, for instance, I would go to August 8th, and midnight. Midnight is a wonderful time to go out and do some astronomy. So I'm going to line it up with midnight right at the top there, like this. I don't know if you can see that well. Okay. And what you end up getting is a picture like this. So what you do is now you find the north, right? You find the cardinal direction north, and you point this north. And what you end up getting, if you hold this up to the night sky, is a map of the night sky and what you see. So this is a really useful tool if you're going out and you are trying to find some stars. You're not 100% sure what you're looking at. This is a really, really useful and valuable tool. And I'll come back to this a little bit later in the presentation because this is super valuable. It's a really useful tool. And another really great way.
Julian, sorry, they can't see you while the presentation is being shared. But the way you were explaining it was excellent because it actually gives them a guide to go back to.
Oh, they can't see me?
They
really?
can't see you while the presentation is shared. You have to switch views if you want them to see something that you're doing in person. I can see you, but they're set up as participants. They can't.
Oh, that's too bad. Did they get anything out of what I just said?
I think so, but for later, you'll have to be careful to maybe at the very end when we end the presentation, you can show the couple of materials then.
Yeah, sure. Yeah. Okay. Yeah, that's fine. For what it's worth, yeah. Okay.
Go ahead.
Yeah, that's fine. For what it's worth, like this other thing is.
Oh, they were able to see it. Okay, they were able to.
Oh, they were able to see it.
Okay.
Oh, okay. Then that's good too. Then.
Yeah.
The other thing that I wanted to point out is another really great way to look for stars, right? Is looking, with your phone. And if you haven't already downloaded something like this, I would highly recommend getting like a sort of stargazing app to keep you company, I guess, when you're doing astronomy. I have one here. It's probably worth pointing out. And I'm not sure if you can see that. It's called Star Chart. I have an iPhone, incidentally. It's something called gyroscopic, which means if you move your phone around, or point it towards the night sky, it can help you identify what you're looking at. It's really fantastic and totally worth an install. It's free, and if you have an Android, there are definitely free equivalent apps. If Star Chart isn't on the Android store. And if you're the camping type, it's really fun to look up and know what you're looking at. So these stargazing apps are super valuable. They're a really good tool, and coupled with like a star finder, you really can't go wrong. You can really start to get a grasp of the pictures in the sky and the constellations you're looking at. It's really a lot of fun. This weekend we'll also get to see the moon. Now, as many of you know, the moon, if you look up every night for a few nights, you'll notice that the moon kind of changes shape in the sky. And these are called the phases of the moon, right? The moon goes through these phases as the sun's light hits it from different angles, right? So in this diagram, I think this is a pretty, like a really nice diagram to see kind of what's happening here. There are arrows on the left-hand side of the screen, from my perspective, that are like illustrating like the sun's light and where it's coming from, right? So you can see that Earth is kind of lit on that side. And the moon, as it kind of travels around the Earth, is being hit by this light, and is reflecting, different amounts of that light. So when it's a new moon, it's completely in shadow, right? You don't get to see the moon. But when it's a full moon, It's capturing all that. It's reflecting all that light off of its surface, and you can see the moon clearly. And as it rotates around the Earth, you know, it reflects different amounts of light, and so you get ultimately a different shape. Now, as I understand it as well, again, our one and only esteemed guest here, has a moon gazer's guide, right? Kind of like mine here. You can see that. Let's take a look at the other side first. This is kind of what I was describing earlier. You can see the phases of the moon here on the back. A new moon when it's completely covered in shadow, and a full moon when it's, when you can see the entire moon here. Of course, the moon isn't physically changing, right? That's an important thing to understand. It just looks like it's changing shape. It's just the shadow and the light appearing and disappearing and hitting the moon differently. This weekend, incidentally, is what we're going to have something called a waning gibbous, right? And that one is this picture right here. That's actually the animation I have on screen. It's waning as opposed to waxing when the moon is starting to get smaller. And a gibbous is what astronomers call that shape of the moon there. Like it's done being a full moon, and now it's starting to get smaller until it's going to become a new moon. I think you can also see how a lunar and solar eclipse work here, but we won't get too much into that. There won't be an eclipse this weekend. You can also see on the other side, really cool, big high resolution image of the moon's features. On the actual moon itself, it's really nice. In real life, it's a little bit tricky with the naked eye, just your eye, to pick out some of these like really fine details. But with a telescope or a pair of binoculars, which are really good for astronomy, by the way, often get overlooked, with this moon gazer's guide, it can help you pick out, some of the moon's features, many of which have been actually named by astronomers. Now, you might notice that there are some darker regions here. These are kind of the regions that have been named. These are called mares. That's M-A-R-E, which is Latin. That's Latin for sea. And these regions appear a little bit darker because of the iron in them. Like iron, the element, kind of the metal, right? And at the bottom here are some of the pictures that people kind of see in the moon, like the man in the moon, a beetle, a woman in the moon, kind of so on. To be honest, I don't really see the man in the moon all that well. That's just me. But like I said, the detail's really cool. I love looking at the moon in detail. But for the best viewing experience, binoculars are definitely the way to go. They work surprisingly well. Yeah, don't overlook them. If you have a pair lying around, I think it's definitely worth pulling them out and looking at the moon with them. Now, some of you may be excited to hear that this is a great time to see planets. Jupiter and Saturn are particularly bright in the night sky these days. As I understand it, Mars and Venus you can see as well. If you've never seen Mars before, it is a stunning red. Like, wow. Once you see it for the first time, you'll never not see it. And Jupiter and Saturn are super bright too. They really pop the first time you see them. At least for me, that was my experience. And I say that because if you don't know any better and you just look up, it can actually be a little tricky to tell the difference between a planet and a star, because they're just both really bright dots. But actually, once you know what to look for, they really pop out. It's unbelievable, and that's when apps like Star Chart come super in handy. That's when your Star Finder comes in super handy, because it can help you locate these things in the sky. Differentiate what's in the sky, what's a star, what's a planet. It's super useful. And I'm going to return just to the Starfinder for a minute. You might notice that the Starfinder you have doesn't actually give the exact planet locations, right? But it does have this like yellow kind of circle here, right? Which is called, it's labeled here the path of the planets. So that's the path the planets take in the sky. Right, and that's because the planets don't actually travel at the same speed in the sky as stars, right? They actually follow this line here called the ecliptic. Right? That's called the ecliptic, which is the plane of our solar system, because our solar system is flat. Right? The word planet actually comes from the ancient Greek word planetes, which means wanderer, because they kind of wander throughout the sky, unlike all the other stars. Which is super interesting. I think that's really cool that even the ancient Greeks kind of knew the planets were special. That's really fun. If you take a look at this infographic here, just like spending a little bit of time on that, what you see here are, I took right off of this website, timeanddate.com/astronomy/ and it tells you, relative to where you live, the rise and set times of the planets. So you can go out and you can take a look at when Jupiter and Saturn are out. You can go out in the sky and take a look at them. Now it does say that Uranus and Neptune, they rise and set. They're on this infographic here, but they're not actually visible to the naked eye. You need a pretty good telescope to see Uranus and Neptune. But it's kind of neat to know that they're there. Apps like Star Chart will definitely point them out for you if you point your phone at the sky. But if you actually look at that part of the sky with your eye, you won't see anything because they're just too far away, and they don't give off enough light. They don't reflect enough light to be seen. But Jupiter and Saturn actually are a fantastic show for people who have binoculars. Or people who have a camera with a really decent zoom and like that gathers lots of light. Because with either of those things, it's actually possible to see the 4 largest moons of Jupiter. And for Saturn, you can actually see that it has rings, or at the very least, like it's not a perfect sphere, right? It's got like a little bump. It looks really, really nice, depending on if you can do that. So yeah, definitely worth looking at the planets this weekend, and coming into in the coming months. It's really fun. This is a picture I found online of Mars in the sky. Honestly, though, I don't want this to be like a substitute for the actual thing. This picture really doesn't do it justice. It's a little bit blurry too. I'd honestly just recommend going and seeing it for yourself because it's really cool. It's really fun to be out there. Yeah, so I figured I'd bring this up now. Figured I'd mention this now because if I don't, I think a lot of people watching this now will go out there and they'll say, Julian said I could see this, but I can't see anything. So one of the major difficulties facing your astronomy endeavors this weekend, especially going into the Perseids, the meteor shower, is if you plan on doing your astronomy in a city or like a particularly well-developed suburban area, it's going to be light pollution. Light pollution is a huge problem facing amateur and professional astronomers. Our cities absolutely blast light into the void of space, 24 hours a day, 7 days a week. And what that does is it makes it a challenge to see the dim lights of stars coming from light years away. So this photo here is of a heat map of, particularly light polluted areas in the United States and the lower half of Canada. The observant among you might already see Montreal, some other cities like Calgary, Edmonton, Ottawa, Quebec City, Toronto, as being like these huge white splotches on the map to indicate like just how bright these places are. Vancouver is a little bit less so, I believe, according to this map at least. Believe it or not, Montreal is notoriously bad for light pollution, worse than New York City, believe that or not. So it's been given this affectionate nickname, the Montreal Nebula, which like it's affectionate, but it's kind of unfortunate. But jokes aside, just be aware of that. It can be a bit of a challenge, but here's a visual difference between different levels of light pollution. It's pretty obvious. There's a massive difference, right? There's definitely a lot more detail in a sky where the lights of the cities, like, I don't know, it isn't getting in the way, isn't interfering with your viewing experience. If you do happen to get out of Montreal for a while and you do some stargazing, it really is like it's super dazzling if you get a chance to go out, with or without a telescope. And I highly recommend it, not just because I'm into astronomy, which I am, obviously, but because I don't think people get enough time to just go outside and observe like the natural beauty of our night sky. So yeah, definitely get out there and take a look at that. And a bit of a bonus challenge, if you're going up north this weekend or soon, or plan to be in a place away from civilization and away from light pollution, thing I'd highly recommend keeping an eye out for is the arm of the Milky Way galaxy pictured here. If you haven't seen this yet in person, I think you really need to. It's fantastic. It may not be as ridiculously prominent and gorgeous as this, but it's definitely there. Depending on where you go, that is. Anyway. And of course, lastly, the last topic on our list of things we're going to be able to see is the Perseids Meteor Shower. And this is, so I'm going to address the question that came up at the very beginning in this little bit here, like where do meteors come from, right? And I think that's a super good question, by the way. I'm really glad that you asked it, because I guess there are a lot of ways to start talking about like the Perseids, and so maybe the right place to start is like what is a meteor shower kind of to begin with, and maybe we'll learn a bit of terminology along the way, right? So there are these space rocks, right? And they begin just as rocky, floating debris in space, right? And that's what we would call a meteoroid, right? Meteoroid, right? And when that rock enters the Earth's atmosphere and begins to burn up, leaving a burning trail behind it, that is what we would call a meteor, right? That's what you see, right? It goes like colloquially by the name shooting star, but it is a rock, okay? It is not a star. Now, some of you might be, disappointed or relieved, depending on who you are, to hear that the Perseid meteors aren't terribly big, right? In the most likely case, none of these space rocks will be, hitting the ground, and they'll likely just burn up entirely due to friction with the atmosphere. But if, by chance, like a meteor, like some hypothetical meteor, were to pass through the atmosphere and hit the ground, we'd call that a meteorite, right? And so kind of here pictured are kind of the three words I just used to describe space rocks. Here, floating out in space is a meteoroid. In the lower right hand corner is kind of like an artistic rendition of a meteor burning up in the atmosphere. And like, fortunately, some of these meteors do end up reaching Earth, and so scientists can pick them up. Some actual just normal people, they pick them up, and that's called a meteorite. So that's an actual space rock. And I think another question that a lot of people end up asking are, what about comets? Are they meteors as well? And interestingly, if you take a look at what meteors and comets are made out of, they're actually super different, right? Meteors come in all shapes and sizes, but they're almost always made up of rock and metal, usually silicon, nickel, and iron. And their bright streak that streak you see in the sky is caused by it burning in the atmosphere, right? In fact, these meteors usually burn different colors depending on like the metal inside them, their composition, which is super, super cool. Whereas comets, on the other hand, they aren't made of rock, actually. They're made of ice and other like vaporizable materials, right? Comets are also characterized by that amazing tail of gas and dust that you see, right? Which actually isn't produced by burning in the atmosphere. Actually, their tail is produced when the comet gets too close to the sun. So while the two share some similarities, and it is easy to get confused sometimes, make no mistake, the Perseids are meteors and not comets. Now, incidentally, the picture I chose here for the comet is a picture of a comet that actually came by super recently. It's called Neowise. It's a comet that passed really close to Earth in late July, I believe. Now, some of our astronomers at the RASC definitely caught a glimpse of it, and they took some photos, and the photos are up on Facebook. And their astrophotography is absolutely brilliant, by the way. It's super, super beautiful and gorgeous, and like the photos are definitely worth taking a look at. And it's a good thing they did it too, by the way, because Neowise, if you didn't get a chance to see it in person, unfortunately, it's not coming back for another like 6,800 years or so. So these photos are probably going to be one of the only ways you can enjoy the comet for the next 7,000 years, unless you happen to have a time machine. So, yikes! But hey, look on the bright side, okay? Fortunately, the Perseids are not one of those like 7,000 year meteor showers. They're actually seasonal, which means they occur regularly. They occur once a year. But that still raises, right, an interesting question, right? How can these meteors be so regular, right? Where do they come from? And do these meteors just fly in from space at the same time every year, right? Well, no, actually, that's a common misconception. Or people just don't know altogether. But to understand why it's not that, we need to look at another infrequent visitor of our solar system. So this is another comet, actually. So in our solar system, there's this comet called Swift-Tuttle, okay, which crosses the orbital path of Earth, like the path we take around the sun, every 130 years or so. And Swift-Tuttle last came by in 1992 and isn't expected to be back until 2126. But every time it passes by, it leaves behind this cloud of fragments in its wake, in its trail. And every mid-August or so, you know, about now-ish, August 12th, a couple days from now, right? The Earth plows right through this cloud of dust, right? It just goes boom, right through it. And this comet debris ranges in size from grains of sand to small rocks. And that is what burns up in the atmosphere as we pass through this giant cloud of dust. And that's what produces the streaks in the sky. And like that's the Perseids Meteor Shower. It's this debris left behind by this comet. So in other words, the meteors, right, they're not coming to us, right? We're coming to the meteors, right? We're coming to the cloud, if that makes sense at all. Another question that comes up when talking about the Perseids is, you know, why are they called Perseids in the first place, you know? And they're called Perseids because they appear to us, you know, as the humble observers on Earth's surface, to be coming from the constellation Perseus in the sky. Meteor showers tend to be named after the constellation they seem to come from, right? There's another meteor shower called the Geminids, right, which they have their peak in December, I believe, and they appear to originate from the constellation Gemini. But there are others like the Leonids, which radiate from Leo, and so on, right? The constellation itself, Perseus, has its origins in ancient Greek mythology as a Greek hero who slew Medusa. And maybe you can make that out on the picture on the right there. He's holding the head of the Medusa in his hands, which is kind of cool. And that being said, they weren't always called Perseids, and certainly aren't called Perseids everywhere on Earth. As early as 36 AD, like Chinese writing has been found, which talked about the same meteor showers we see today. And European Catholics also refer to the Perseid showers as the Tears of St. Lawrence, since the meteor showers coincided with the anniversary of his death. So you know, cultural differences, they're not called Perseids everywhere. Now, interestingly, the Perseid meteor showers don't just start in August, but span a wide range of dates from about mid-July to late August, as I understand it. So, you know, what's this August 12th number about? That's what we call the peak of the Perseid shower, when they're the most visible. So this is like the best time for people to go out and experience the meteor shower. Because when it's not, you know, when it's not the peak, like outside these peak dates, you can still catch glimpses of it, but unfortunately, they're a little far and few between. And actually, this year during the peak nights of about August 11th, August 13th, right, we're actually super lucky, right? There's going to be a waning crescent moon, which is ideal for maximum viewing of the meteors. And on those nights, you can expect to see easily 30 to 60 shooting stars per hour, which is super nice, super fantastic. Now here in this slide, I'm actually just pointing out again what I just said, that this year we're super fortunate to have a waning crescent moon up in the sky during Perseids. Last year, the astronomers were unlucky, right? So they had a waxing gibbous moon while they were trying to look at the Perseids. So this is actually a bit of a problem, right? So when the moon is a gibbous moon or like a full moon, remember, like there's a lot of light reflecting off the moon, so it can make it a little difficult to see some of the dimmer Perseid meteors. But this year, the viewing conditions will be significantly better because of that crescent moon reflecting a lot less light. So there'll just be more meteors to see, which is fantastic. That being said, though, even though it obviously, you know, it has to be dark enough to see the meteors, and that the phase of the moon will be super helpful for seeing the dimmer of the meteors, excitingly enough, you can actually see some meteors even under like bright suburban skies, like some of them are brighter ones, which is super exciting as well. So if you don't get a chance to go to a super dark place, you know, you can still get a chance to see them, which is great. So we're nearing the end at this point, so I figured at the end I'd have some, you know, hot tips for you guys to view the Perseids. So I think we're going to end with a few of those. Because the meteors radiate from Perseus, right? They come from the Perseus constellation, as I mentioned a bit earlier. You won't actually see all that much if you stare directly at Perseus, at that constellation. You won't see it very much. Lie down on the ground and look directly above you, so you have this large field of view, so you can see as much of the dark sky as possible and see as many meteors as you can. The meteors themselves can actually only be viewed for a super brief moment, right? They burn up very quickly. Like if you blink, seriously, like it's actually literal. If you blink, you might miss them. So it's possible you won't be able to see all the same ones as the people around you, right? It's not like viewing a comet, right? It's not like viewing a comet like Neo was, right? Because everyone sees the same comet, that one comet, whereas there are many meteors coming in the Perseid meteor shower, and they burn up super quick. So you have to be looking up and seeing as many of them as you can. One other really useful tip is that it's not easy for your eyes when you go from the bright interior of your house to the dark exterior of night, right? Your eyes actually need time to adjust and refocus themselves. So I'd recommend going about like 20 minutes early so your eyes can get adjusted. That being said, the tricky part actually is if you're bringing your phone out with you on your astronomy excursion, staring at your bright phone screen breaks your night vision, right? So if you stare right at your bright phone screen, you're not gonna be able to. Your eyes are gonna unadjust themselves, right? And also that'll happen too if you look at streetlights. So it's for this reason that astronomers really like to use red lights on their telescopes and their astronomy instruments, because red light actually is easier on your eyes. So if you can help it, don't look at your phone all too much. But at the very least, like dim your screen on your phone. This won't probably apply this time, but also if you're in public looking at the Perseids, like in a park, like it's kind of like a movie theater. Like no one really likes to see your bright phone screen anyway. It's kind of distracting. So just be aware of that, right? It's pretty much all I have to say on that. And finally, for the best viewing experience, you'll ideally probably want to be going out after midnight and before sunrise. The skies will be super dark, and in fact, in the northern hemisphere, our part of the globe will be facing that comet debris trail. So that's super exciting. There'll definitely be more meteors to see because of that. This kind of brings me to the end of my little presentation. I hope you guys learned a thing or two about astronomy, looking up at the night sky and the Perseids. Now, if you want we've set aside, like I said, like 20 minutes or so for questions, as I understand it. Or if you run out of questions, whichever comes first. So I guess we can jump into that unless there's anything else that, Krim wanted to add or...
That was excellent, Julian. Thank you so much.
Whatever, right?